Hello guys, I'm Ayswarya. Welcome back to Ayswarya's Math Classroom. In the previous video, we solved questions 9 to 12 from the end of chapter exercise of chapter 1, the use of coordinates. In this video, we'll continue with question 13 to 16. As always, I'll explain each questions step by step in a simple and easy way to understand. So let's get started. Question number 13. The midpoints of the sides of the triangle AB are the points D, E, and F. Given that the coordinates of D, E, and F are 5, 1, 6, 5, and 0, 3 respectively, find the coordinates of A, B, and C. Here you can see the triangle A, B, and C, and the midpoint of AB is given as D, and the coordinate of D is 5, 1. The midpoint of the side BC is E, and the coordinate of E is 6, 5, and the midpoint of A and C is F, and the coordinate of F is 0, 3. Here we have to find the coordinates of A, B, and C. Okay, now let us assume the coordinate of A as x1, y1, the coordinate of B as x2, y2, and the coordinate of C as x3, y3. Actually, when we are solving this question, it is bit lengthy, but it is very easy. Since we have done the previous questions using the midpoint formula, this question also will be very easy. But the only thing is that this is bit lengthy. Okay. So now see this side AB. Here you can see D is the midpoint, right? So we can write this as D is the midpoint of AB. The x coordinate of D is equal to the x coordinate of A plus x coordinate of B divided by 2. That is how we find the midpoint, right? So we can write this as x1 plus x2 by 2, which is equal to 5. Then x1 plus x2, when this 2 goes to this side, it will become 5 into 2, and x1 plus x2 is equal to 10, and this we will put it as equation number 1. Then the y coordinate of D, which is 1, it is equal to the y coordinate of A plus y coordinate of B by 2. So we can write it as y1 plus y2 divided by 2 is equal to 1. Then y1 plus y2 is equal to, when this 2 goes to this side, 1 into 2, which is equal to 2, and this is equation number 2. Now taking this side BC, here E is the midpoint, right? So we can write it as E is the midpoint of BC. Then we can write x2 plus x3 by 2, that is equal to 6. The x coordinate of E is 6, right? So this will be equal to the x coordinate of B plus x coordinate of C divided by 2. So that is what I wrote here. X2 plus x3 by 2 is equal to 6. Then we can write x2 plus x3 is equal to 6 into 2. Then x2 plus x3 is equal to 12. And this is equation number 3. Then the y coordinate, we can write it as y2 plus y3 by 2 is equal to 5. Y coordinate of E is 5, right? That is y2 plus y3 by 2. This is equal to, then we can write y2 plus y3 is equal to, the 2 goes to this side. That means 5 into 2. Then y2 plus y3 is equal to 10. That is equation number 4. Now in this triangle, the side AC, you can see F is the midpoint. So here we can write F is the midpoint of AC. Then x1 plus x3 by 2 is equal to 0. Then x1 plus x3 is equal to 0 into 2 means this is 0. And this we can write it as equation number 5. Then y1 plus y3 by 2 is equal to 3. y1 plus y3 is equal to 3 into 2, and y1 plus y3 is equal to 6. This is equation 6. Now we have total 6 equations, and among the six equations, 3 belongs to x, that is here the equation number 1, equation number 3, and equation number 5. See, these 3 equations are x related to x, right? x1 plus x2 is equal to 10, x2 plus x3 is equal to 12, and x1 plus x3 is equal to 0. And equation number 2, 4, and 6. These three equations are y related to 5. So adding the equations 1, 3, and 5, we will get the values for x. Okay, and then adding the equations that is 2, 4, and 6, we will get the value for y. See, now you can see clearly equation 1, 3, and 5. x1 plus x2 is equal to 10, x2 plus x3 is equal to 12, and x1 plus x3 is equal to 0. So here I'm going to add all these three equations. So I can write adding equations 1, 3, and 5. First we'll write the left hand side all together. That is x1 plus x2 plus x2 plus x3 plus x1 plus x3 is equal to 10 plus 12 plus 0. This part first, then plus this one all the left hand side I wrote it here, then the right hand side over here. Then you can see you have 2x1, that is we can write it as 2x1. Then we have 2x2, that is 2x2 we can write. Then again 2x3, and this is equal to 22. We're taking 2 common, 2 into x1 plus x2 plus x3 is equal to 22. Taking the 2 to this side, we can write it as x1 plus x2 plus x3 is equal to 22 by 2, and this x1 plus x2 plus x3 is equal to, this is 11, and you can write this as equation 7, that is x1 plus x2 plus x3 is equal to 11. Now we will, using this equation, we will find the value of x1, x2, and x3. So how we are going to do it? I'm going to write it over here again, this equation, that is x1 plus x2 plus x3 is equal to 11. From this first equation, you can see that x1 plus x2 is 10, right? So this I will write it as 10 plus x3 is equal to 11. Then x3 is equal to, when this 10 goes to the other side, we can write it as 11 minus 10, and x3 is equal to 1. Clear? Again, I would write this equation 7, that is x1 plus x2 plus x3 is equal to 11. From the third formula, that is x2 plus x3 is equal to 12. You can see it over here, right? I'm going to substitute that over here. That means x1 plus x2 plus x3, which is 12, is equal to 11. x1 is equal to 11 minus 12, and x1 is equal to minus 1. So we got the value of x1, which is equal to minus 1. Then again, using the equation 7, that is x1 plus x2 plus x3 is equal to 11. By using the fifth formula, x1 plus x3 is equal to 0, right? Which means 0 plus x2 is equal to 11. Therefore, x2 is equal to 11. So we got the value for x1, which is equal to minus 1, x2 which is equal to 11, and x3 is equal to 1. So these are the values of the x coordinates. Okay, now let us find the values for the y coordinates. See, here you can see the three equations, that is the second equation, which is y1 plus y2 is equal to 2, the fourth equation y2 plus y3 is equal to 10, and the sixth equation, which is y1 plus y3 is equal to 6. So here we are going to add these three equations to find the value of the y coordinates. So we'll write adding equation 2, 4, and 6. We get, so adding the left hand side first, that is y1 plus y2 plus y2 plus y3 plus y1 plus y3 is equal to 2 plus 10 plus 6. You can see there are 2y1. So we'll write 2y1 plus again 2y2. See, 2y2 plus this y3, that is 2y3 is equal to 18. Then taking 2 as common, y1 plus y2 plus y3, that is 2 into y1 plus y2 plus y3 is equal to 18. Then y1 plus y2 plus y3 is equal to 18 by 2. Y1 plus y2 plus y3 is equal to 9. And this is equation number 8. So equation number 8 we are getting as y1 plus y2 plus y3 is equal to 9. So using that equation, y1 plus y2 plus y3 is equal to 9. See, in equation 2, we can see here y1 plus y2 is equal to 2. So here I can write 2, right? In the place of y1 plus y2, I can use 2. So this y1 plus y2, I'm writing it as 2 plus y3, which is equal to 9. Then y3 is equal to 9 minus 2. Y3 is equal to 7. So here we got y3 is equal to 7. Again, I'm going to write the equation 8, that is y1 plus y2 plus y3 is equal to 9. And from the fourth equation, see here fourth equation, y2 plus y3 is equal to 10. So y1 plus 10 is equal to 9. Y1 is equal to 9 minus 10. Then y1 is equal to minus 1. So we are getting y1 is equal to minus 1. Next again, eighth formula, that is y1 plus y2 plus y3 is equal to 9. Then by the sixth formula, I'm going to substitute that. So here the y1 plus y3 is 6 plus y2 is equal to 9. Then y2 is equal to 9 minus 6. Y2 is equal to 3. Now we have all the values of y, which is y1 is equal to minus 1, y2 is equal to 3, and y3 is equal to 7. Now let us write the coordinates of. So we were asked to find the coordinates of A, B, and C. And using the midpoint formula, we already found. So let us write it down. A, we assumed it as x1, y1, right? Then B, x2, y2, and C, x3, y3. So now let us write the coordinates, the values for A, x1, y1. So here you can see I have wrote in this page the values of the x coordinates. So it will be easy for you to write. That is C, x1 is equal to minus 1, x2 is equal to 11, and x3 is equal to 1. And the value of y1 is minus 1, the value of y2 is 3, and value of y3 is 7. So we'll write it down. That is x1 minus 1 and y1 is minus 1. Then b x2 is what? 11 comma, y2 is 3, and x3 is 1 comma 7. So these are the coordinates of A, B, and C. And in this question, we were to find the coordinates of A, B, C, and this is the answer. I hope you understood. Now let us move on to the next question. Question number 14. A city has main roads which cross each other at the center of the city. These two roads are along the north-south direction and east-west direction. All the other streets of the city run parallel to these roads and are 200-meter apart. There are 10 streets in each direction. The first part of this question is that using 1 centimeter is equal to 200 meter, draw a model of the city in your notebook. Represent the road street by single lines. So here, this is a graph. You can represent this in your book, okay, using the graph. Here, two lines which represent the road. This road is in the north-south direction, and this road is in the east-west direction. And they cross each other at this point. This point of intersection, we'll take it as the origin. Okay, and we'll represent it as 0. Then there are 10 streets in each direction. So in each direction, there are 10 streets. And also here, all the other streets of the city run parallel to this road and are 200 meters apart. So this each, so between each streets, it is 200 meters apart. Okay. Then there are 10 streets in each direction. So we'll mark that from this point till here, one street, second street, third street, fourth street, fifth street, and like that towards the down also, and again 5 streets will be there. That's all you have to plot in your graph. If you give different colors, it will be more easy for you to understand. So here total 10 street is there in this direction, parallel to the east-west direction. We have now 10 streets, and parallel to the north-south direction, again we have to represent 10 street. So here from here, here one street, second street, third street, fourth street, fifth street, like that to this side also. Now you can see here using different color, that is orange color. I represent the streets that is parallel to the east-west direction. Using the blue line, I represented the streets across the parallel to the north-south direction. So we are done with the first part of this question. Now let us do the second part of this question. Second part of the 14th question. There are street intersection in the model. Each street intersection is formed by two streets. See here, if you look in this graph, you can see that the streets intersect. This horizontal line, vertical line, they intersect. Okay, and each street intersection is formed by two streets. That is one street, one running in the north south and the other in the east west direction. So one is in the north south, another is in the east west direction. So this here it intersect, right? And each street intersection is referred to in the following manner. That is, if the second street running in the north south direction and the fifth street in the east west direction meet at some crossing, then we call the street intersection 2 comma 5. That means over here in this north south direction, which here we can see is the vertical line. The second street means this is the second street, right? This is the first street, this is second street. Here all the numbers which are given. So this two lines where they met, this will be took as the origin, and here each streets have given as 1 2 3 4 5, and upward again a street 1 street 2 street 3 street 4 street 5. So the second street over here is running in the north south direction, means this street, and the fifth street in the east west direction means this street. So where do the and we can call that the street intersection 2 comma 5. So here this particular point is called 2 comma 5. Okay, let me mark that this point 2 comma 5. You understood? This means this is the second street and this fifth street where they intersect, this point is called 2 comma 5. Now using this convection, find a how many street intersection can be referred to as 4 comma 3. Now if you look, 4 is this line, right, this vertical line, and 3 this one. So this point 4 comma 3, this point is the intersection. So how many street intersect over here? Only one street. So we'll mark that. So this point is 4 comma 3. And how many street intersection? Here only one. Because if you take any other intersection, the reference itself, the coordinates itself will change. So the coordinates where we get 4 and 3 is only one point over here. Now the B part, how many street intersection can be referred to as 3, 4? 3 means this vertical line, right? And 4 here, this point. So here 3 and 4, the intersection is over here. So we'll mark it 3, comma 4. And how many intersection? Here again only one. Only one intersection. I hope you understood. Now let us move on to the next question. Question number 15. A computer graphics program displays image on a rectangle screen whose coordinate system has the origin at the bottom left corner. The screen is 800 pixel wide and 600 pixel high. A circular icon of radius 80 pixel is drawn with its center at the point A, 100, 150. Another circular icon of radius 100 pixel is drawn with its center at the point B, 250, 230. So with this information, we have to draw the Cartesian system. So here, this horizontal line is the x-axis and this vertical line is the y-axis. So here I am taking 1 unit. 1 unit is equal to 100 pixel. Okay. So here on the x-axis, you can see this is 100, 200, 300, 400, 500 till 800. Only till 800 is needed. Okay. And on the y-axis, 100, 200, 300, 400, 500 till 600. Because the screen is 800 pixel wide and 600 pixel high. So from here, this 800 and 600, this is the point. And if we join it, we will get a rectangular screen. Okay, so this is our rectangular scheme where it is 800 pixel wide and 600 pixel high. A circular icon of radius 80 pixel is drawn with its center of a point 100 and 150. So here this point is 100. So this is 100 and this center part will be 150. So here this is 100 and in between this over here will be 150. So we will take a point over here. Okay, so the point will be over here. Now I'm not going to write the coordinates. Later we'll write it. Okay, since we have to draw a circle. And one more thing in this question, compass is required because to draw the circle we need a compass. So rather than the pencil and scale, we need a compass also. Okay, now this is a point. One is 100 and the other is 150. And this is point A. We'll mark it later. Then next point B, where the first x coordinate is 250. 250 means the point will be this over here, and 230 will be over here. Okay, so 250 and 230. This is the point B. Now we have to draw a circle. That is circle icon of radius 80 pixel. 80 pixel means 0.8 centimeter. Okay, so we will draw a circle with a radius 0.8 centimeter. Now you can see I have drawn a circle taking the radius as 0.8 centimeter. So this is the circle we are getting. Now we have to draw another circle with the radius 100 pixel. 100 pixel means we will take 1 centimeter. So taking the radius as 1 centimeter, then we have to draw a circle for this point. So this is a point A where the coordinates are 100 and 150, and we have to draw another circle over here using the radius 1 centimeter. So let us draw that circle. So when we draw a circle with 1 centimeter, this is how we are getting the circle. For the circle, the coordinate, this is point A, coordinates 100, 150, and this is point B. The coordinates are 250, comma 230. I didn't write the coordinates before because the we had to draw the circle, right? That is why after drawing the circle, I'm writing the coordinates now. So here, what did we do? We took the coordinates of the point A, that is 100 and 150. We got the center. Then taking the radius as 0.8 centimeter, we were able to draw the circle, and next circle using the points 250 and 130, we got this point using the radius as 1 centimeter, because here it is given as 100 pixel, right? So we are taking it as 1 centimeter, and we were able to draw the circle. Now we got two circles over here, and the first part of this question is whether any parts of either circle lies outside the screen. So if you look in this graph, you can see that these two circles lie inside the screen. They are not outside the screen. So you can write it as, so you can write the answer as no, any parts of either circle does not lie outside the screen. Okay, so the by seeing the figure itself, you can understand that this is, two circles are inside the screen. They are not outside the screen. And the second part of the question is that whether the two circle intersect each other. So make sure when you're drawing the circle, use a compass. Take this 0.8 centimeter, 1 centimeter, that correctly. So you can see that the two circle intersect each other. So you can write yes, the two circles intersect each other. I hope you understood. This was an interesting question, right? So, for this, you need a compass and take the measurements correctly and draw the circle. So, I hope you understood. So, now let us move on to the next question. Question number 16. Plot the points A 2, comma 1, B minus 1, comma 2, C minus 2, comma minus 1, and D 1, comma minus 2 in the coordinate plane. Okay, now let us plot this first in the graph and then we'll go to the next part of this question. So taking the points A, which is 2, comma 1. So here this is a graph. You can see horizontal line is the x-axis and the vertical line is the y-axis, and I have marked the points. On the right side, you can see 1, 2, 3, 4, and on the left side of the x-axis, -1, -2, -3, -4, and on the upward direction, which is here my 1, 2, 3, and downward it is -1, -2, -3. Okay, so on this graph we are going to plot the points. First it is A, that is 2 comma 1. So 2 on the x-axis and 1. So this is our point. We'll mark it over here. So the next point is B, -1, 2. -1 on the x-axis and 2. 2 is over here on the y-axis, which is positive. So we'll mark it over here. Uh, -1 and 2, this point. Okay. Next is C, -2, -1. Both the numbers are negative. So first is x -2. This is -2 on the x-axis and -1 on the y-axis here. So this is the point. We'll mark it over here. Next is D, 1 comma -2. So where is 1? 1 over here, 1, then -2 over here. So this is our point. Now let us mark it over here. Now we have to join all the points and also name it. Now let us mark the points. This is A, this is B, this is C, and this is D. Now, see, we have plotted all the points in this graph, and the question here is ABC a square? For that, we will use the distance formula. Okay, using the distance formula, we will see whether all the sides are equal. Now let us write distance formula is equal to root x2 minus x1 the whole square plus y2 minus y1 the whole square. Now let us find distance of AB. AB is equal to, for this AB, this is x1, right? This is x1, y1, and this is x2, y2. So now let us write root x2, x2 is -1 minus 2 the whole square plus y2 is 2 minus 1 the whole square, and this is equal to -3 the whole square plus 1 the whole square is equal to root -3 into -3 is 9. 9 plus 1, which is equal to root 10 units. Okay, next is BC. BC is equal to, now here, in BC, this is x1, this is y1, and C, this is x2, y2. So taking the points, root x2 is what? -2 minus -1 the whole square plus y square. Y square is -1 minus 2 the whole square, and this is equal to -2 plus 1 the whole square plus -3 the whole square, and all this in root is equal to root -1 the whole square plus 9, which is equal to root 1 plus 9, and this is equal to root 10 units. Okay, next is CD. CD is equal to, here this is x1, y1, this is x2, y2. So we can write root x2 is what? 1 minus -2 the whole square plus -2 minus -1 the whole square, which is equal to 1 plus 2 the whole square plus, and this is -2 plus 1, -2 plus 1 the whole square, and in root. Don't forget to put the root. Okay, when I'm telling, I might sometimes forget to say the root, but always the root is there. Then, and this is equal to root 3 square plus -1 the whole square equal to 9 plus 1, which is equal to root 10 units. So for CD also we got root 10 units. Now we have to find for AD. AD is equal to root, what is x2? x2 is 1. 1 minus 2 the whole square plus y2 is -2 minus 1 the whole square. Okay, so y2 is -2 and y1 is 1, so that whole square. Then root 1 square plus -3 square, and which is equal to 1 plus 9, that is equal to root 10 units. Now you see here AB, BC, CD and AD, they are all equal. So all the sides over here are root 10 units. It can be a square, it can also be a rhombus. Okay, So here for square, we know that all sides are equal. Sides are equal. And for rhombus also, all sides are equal. But the thing is that for square, all diagonals are also equal. But in the case of rhombus, the diagonals are not equal. So we have to check with the distance formula whether the diagonals are equal or not. So again, diagonals equal means if these two sides, that means if AC and BD, these two diagonals are equal, then we can say it is square. If the diagonals are not equal, then it is a rhombus. Now let us check the diagonals are equal or not. The diagonals AC. Okay, so here using the same again distance formula, AC is equal to, this is x1 y, okay, y1, then this is x2 y2, right? Then we can write this as AC is equal to root x2 is minus 2 minus x1 is 2, this whole square, plus y2 is minus 1 and y1 is 1. So minus 1 minus 1 the whole square. And this is equal to root minus 2 means minus 4 the whole square, plus minus 1 is minus 2 the whole square, right? And this is equal to minus 4 into minus 4 is what? 16, plus, so this will become 4, so inside the root, and this is equal to root 20 units. Okay, for AC this diagonal we are getting root 20 units. Next is BD, so this is, so here this is x1, this is y1, and this is x2 y2. Okay, so we'll write it as root, what is x2? 1. 1 minus y, x1 is minus 1 and this whole square, plus y2 is minus 2. Minus 2 minus y1 is 2 and this whole square. And this is equal to root 1 minus 1, which is 2 the whole square, plus minus 2 minus 2, which is minus 4 the whole square, and this is equal to root 4 plus 16 equal to root 20 units. Now you can see here the diagonals both are equal. So here if you look, the sides are equal, root 10, root 10, root 10, all the four sides are equal, and the two diagonals are also equal. So we can write, therefore AB is equal to BC is equal to CD is equal to AD, and this all is equal to root 10 units. AC is equal to BD, which is equal to root 20 units. So here all the sides are equal and the two diagonals are also equal. So we can say that this is a square. Okay. So therefore A, B, C, D is a square. Next one. What is the area of the square? What is the area of the square means we have to find the area of the square. So area is equal to, what is the area of the square? Side the whole square, or side into side. Here the side, we found the side is root 10, right? So root 10 the whole square, which is equal to the square and root cancels, and we'll get the answer as 10 square units. So while writing the units, don't forget to include the square. In area, we have to mention square units. Okay, so the answer is 10 square units. I hope you understood. So by this question, we have finished all the questions of end of chapter exercise, and we finished this chapter. I hope you understood this chapter. So if you like my video, please do like, share, and subscribe. And thank you for watching.